Okay, so there are some questions on projectile motion and some on linear motion and free fall. It contains almost all questions, but let's check them out. Let's check them out. So there's question 10 there. Unfortunately, we have to start with question 10. So question 10 is saying a ball is thrown down vertically, or a ball is thrown vertically upward and it returns to the ground after time of 60 seconds. Question A, what is the initial velocity of the ball? What is the initial velocity of the ball? Question 2 is saying, what is the maximum height uh, the ball reached? What is the maximum height the ball reached? Okay, so we've only been given time here. We've been given time to say the time it took this ball to go up and come back down was 60 seconds. Okay, so if a ball is thrown in that manner from there, it goes to the sky and then comes back again at the same point, and then it took time of 60 seconds like that. So the question is A, we should find the initial velocity U, and then we should also find the maximum height H. B, we should find the maximum height reached H. Okay, so if you remember last week when we were discussing projectile motion, I said if you have such a diagram or such a trajectory whereby you are throwing something into the atmosphere and then it is going up and coming back down again at the same level. We call that a symmetrical type of projectile motion. And what does that mean? That means the time it takes this ball to reach its maximum height will be the exact same time it will take this ball to move from the top there until it hits the ground. So we know one thing to say. When an object reaches the maximum height of its trajectory, it is going to stop for an instant before it starts coming down. So we know to say when going up, there is negative g as acceleration, whilst when coming down, there is a positive g of acceleration. So what can I do here? They've told us to say we should find the initial velocity u. And how am I going to approach that? I'm going to use motion or the motion up to that point, up to the maximum height h. What do I know up to that maximum h, our maximum point h? What I know is that the final velocity at the maximum point is 0. What else do I know? I know to say acceleration is equal to negative 9.81 meters per second squared, like that. So what am I going to do? I'm going to introduce this equation to say final velocity is equal to u, which is initial velocity, plus acceleration multiplied by time. What's the time taken for the boat to reach the maximum height? We say this is a symmetrical diagram, which means the time is equally divided what's going up and what's coming down. So we're dividing this 6 seconds by 2, and we're going to get the time it reaches to reach the maximum height as 3 seconds, like that. So if we have that information, we know to say final velocity is 0. So I'm going to say 0 is equal to initial velocity plus acceleration, which is a negative 9.81, multiplied by time, of which in this case, time is 3 seconds. So I'm going to say 0 is equal to initial velocity plus, I have negative 9.81, multiplied by 3. Okay, I'm getting plus negative 29.43, like this. Okay, so I'm going to get this distance and take it to the other side. So I'm going to remain with u is equal to 29.43, and this is initial velocity, which means it is in meters per second. Any question on this one? Any question on this one?
May you kindly explain on the velocity part why we're equating the velocity to 0?
Okay, so I've said for us to find the initial velocity from this point here, the initial point, what are we doing? We're going to use motion, which is only starting from the initial point there until this object was at its maximum height. And we know to say whenever we're dealing with projectile motion, when an object is at its maximum height, the final velocity, it reaches the final velocity of 0 meters per second. It is going to stop just for an instant before it starts coming down. Before that rapid change of motion there's an instant whereby this object is going to stop. Hence, when starting from the ground here, we're going to say the final velocity is equal to 0. Whilst when starting from the top there, going to the final point there, we're going to say the initial velocity was the one which was going to be 0. So in this case, since we're going up, it is going to stop at the top, so final velocity is equal to 0.
Oh, okay, thank you.
Okay, now that we found the initial velocity, let's find the maximum displacement h. So what do we have? We have initial velocity, we have the time it takes to reach the maximum height. So which formula can we bring in order for us to find the maximum displacement? The maximum displacement,
I think the one that says v squared is equal to u squared plus this 2as.
okay, so v squared is equal to u squared plus 2s like that. Okay, very good. So we're going to say our final velocity is 0. Our initial velocity is 29.43. This is squared plus 2. Acceleration is negative 9.81. Then we have s at the end there for our displacement. So you can use both formulas here. Since we also have time, it's okay if you use s is equal to ut plus half a t squared. Since we know to say the time it takes this object to reach the maximum height is 3 seconds, we can just plug in the time there and we are going to get the correct answer. But since in this case we've chose that one, let's continue with this one. So I would say 0 is equal to 29.43 squared. What's the answer? Okay, so 866.1 plus, okay, so this will become minus. Let me just put a minus. Minus 2 multiplied by 9.81. This is giving me 19.62. So minus 19.62 s like that. Okay, so I'll say 19.62 s is equal to 866.1 over 19.62, even this side over 19.62. Cancel out the 19.62 here. I'm having my s is equal to 866.1 divided by 19.62. Okay, so I'm getting my final displacement of 44.14 meters. And that is the maximum displacement in the y-axis, the maximum height reached by the object. Anyone with a question, guys? Okay, if there's no question, I can move on to the next question. I can move on. Okay. So that was all in question 10. Let's look at question 11. Question 11 is saying a ball is dropped from a height of 100 meters above the ground. At the same time, a second ball is thrown vertically upwards from the ground with an initial velocity of 50 meters per second. Question A, determine the time at which the two balls pass each other. Question B, at what height above the ground do they meet? Question C, what is the velocity of each ball at the moment they meet? Okay, so this is a very, very interesting question. It requires someone to brainstorm. Okay, so this is what we have. We've only been given two things here. We've only been given two things. So this is what we have on question 11. We have, let's say we have a height of 100 meters to the ground like that. Okay, so let's say we have the height of 100 meters, then one ball is thrown down. This is 100 meters. Like that. Then one ball is thrown down. Whilst one ball is thrown up. Like that. Is the first the first ball is not thrown, it is dropped. Remember, we have to take note of this language, right? If they say it's dropped, that means the initial velocity was 0. So ball A was dropped, then ball B. So I'll say this is ball A or ball 1, or this one is ball number 2. So this is ball number 2. This one is ball number 1. So ball number 2 was thrown up with an initial velocity of 50 meters per second. And what else do we know? We know to say for this one, which is dropping, it is going to have an acceleration which is equal to 9.81 meters per second squared. Whilst this one, which is going up, it is going to have an acceleration of negative 9.81 meters per second squared. Okay, so they've asked us to say, in part A, what have they said? They've said, determine the time at which the two balls meet each other or they pass each other. So what are we going to say here? Or how are we going to analyze this question? This is what is happening. We are going to have to take the distance that is covered by the ball that is thrown upwards to meet the other one as x. So this one, the distance that the ball number 2 here is going to cover to meet this one, to meet the ball number 1 here. Let's call that distance as distance x, like that. Then the distance that is going to be covered by the ball number 1 here to reach where ball number 2 is, we are going to call it what? We are going to call it 100 meters minus x. Why? It's because we're subtracting the x that has been covered by this ball, which is down here, whilst the ball 1 is falling from a height of 100 meters. Are we together there?
Yes.
Okay, so
Yes.
the distance covered by B1 will be 100 minus x meters, whilst the distance covered by B2 here will be called what? It will be x meters, like that. So from here now, what are we going to get? Or what are we going to say? I've already named them B1 and B2. So for this ball that is dropping from the top now, we've said we know the acceleration to say the acceleration is 9.81 meters per second. And this guy has been dropped, which means the initial velocity is equal to what? It is equal to 0 meters per second, like that. So we can now bring in our equation of motion and plug in what we've just discussed here. So we're going to say S, which is the distance covered, will be equal to UT plus half AT squared. How many things do we know from the equation that we have? How many things do we know in this equation in terms of ball number 1?
We know the distance, the initial velocity, and the acceleration.
Okay. So we are going to say the distance is what? The distance is 100 minus x. This is equal to what? This is equal to the initial velocity of ball number 1. This ball is being dropped, which means the initial velocity is 0, which means it takes out that part of the equation. Because this is a 0, so we can ignore it. So we're going to remain with half multiplied by the acceleration, which is 9.81 multiplied by t squared, like that. Okay, so this is what we have from the ball number 1. So we're going to have 100 minus x. This will be equal to 4.9 t squared. So we can label this as our equation number 1. We can now go to ball number 2. What do we know about ball number 2? If we use this same equation, we know the initial velocity. We know the distance, to say the distance is x meters. And we know the acceleration. So what are we going to say? We're going to say for ball number 2, the equation of motion is going to be equal to x. Okay, so I say x is equal to the initial velocity they've given us to say it's 50 multiplied by t. Then since the acceleration is negative, we're going to say minus minus half, which is that half we're still multiplying by the 9.81, so minus 4.9 t squared. I guess this equation should be like this. Okay, and we can label this as our equation 2, like that. Okay, so from here, where else can we go with this equation? Anyone who has an idea where are we going to go with this equation? Or with these two equations, since now we have two equations. We have this one which is here, and we have this one which is here. The time is the same, the x is the same, which means these two equations are missing the same thing. So what are we going to do about them? Anyone with an idea? Okay, so we are going to add these two equations together. How are we going to do that? You're going to add the left-hand sides of the equation, and we're also going to add the right-hand sides of our equation. That's the only way we can solve this question. So we're going to say 100x minus x plus this x that is down here. So let me remove the b2 here. Okay. So 100x minus x plus the x that is down here. So I'm going to have 100 x minus x plus this guy who is here, x. And this will be equal to what? It will be equal to the 4.9 t squared, 9t squared, plus this guy which is down here. Just the way it is, we take it and plug it into our new equation that we're supposed to come up with. So 4.92 plus 50 t minus 4.9 t squared. Okay. From here, what are we going to have? We can see to say negative x plus x. This will actually terminate the x from the right-hand side of our equation. So we're going to have 100 being equal to 4.9 t squared minus 4.9 t squared. It will terminate that side of that part of the equation. So we're going to have 100 is equal to 50 t. Divided by 50, divided by 50. This cancels out. We remain with it. Our t is equal to 2 seconds. Have we seen what has just happened here? Hello? Your network is breaking. I can't get anything. Your network is breaking, so I can't get anything. Okay, so that is the time that is taken for the two balls to meet. They are going to meet when, or they are going to pass each other when the time is exactly 2 seconds. That means we've found it, or we've calculated the question A. Let's go to the next one. Question B is saying, at which height above the ground do they meet? At which height above the ground do they meet? Okay, so we can calculate this using the motion of ball number 2. Since we know the time that it takes for them to meet, we're going to say ball number 2's motion, B2 motion. We have initial velocity, which is equal to 50 meters per second. We have acceleration, which is equal to negative 9.81 meters per second squared. We have the time that they meet to be equal to 2 seconds like this. Okay, so from this now, which formula can we use in order for us to find the displacement above the ground? The displacement that ball number 2 is going to travel in the 2 seconds.
The one where just from using the one for S is equal to UT.
Okay, so S is equal to UT plus half AT squared like that. Okay, so we're going to say displacement S is equal to 50 multiplied by 2 minus half 9.81 2 squared here. Okay, so I'm going to have my S is equal to 100 minus 4.9 being multiplied to a 4 there, since 2 squared is equal to 4, of which my S will be equal to 100 minus 4.9 multiplied by 4, 19.6. Okay, so S is equal to 100 minus 19.6. 100 minus 19.6. 80.4 meters. Which means from the ground, it was going to be 80.4 meters. Unless anyone has a question on this one.
For me, I've got a question.
Yes, yes.
So, like the way they said, we find the height at which the two balls met. Does it mean if we are to use the motion for like the first one, we have to subtract it from 100 to get the downward distance which remains?
I think it's supposed to work like that, since
Okay.
everything is taking place at the same time. Because if you drop that ball, that means after 2 seconds, it's still going to be at the same height. Now it's just that the one that is falling, it is starting from 100, right?
Yes.
Yeah, so if you find the distance, you can say 100 minus that same one in order for you to get the displacement from the ground.
Okay.
Okay, so if that's all for part B, we can move to the next one. Part C, which is saying, what is the velocity of each ball at the moment they meet? What is the velocity of each ball at the moment they meet? So I don't think this should be a very big deal. The final velocity of bore number 1 and the final velocity of bore number 2 when they met. So which equation can we use here? We know to say the first one is starting from initial, whilst this other one is starting from 50. We can say velocity is equal to what? Anyone who can suggest the formula? Our goal is to find final velocity.
I think we
So
can
I
use the
think
one for
even this one, which is V, is equal to U plus AT. This one should work right here, right? Because we have the initial velocity, we have the acceleration, and we have the time. So for bore number 1, I'll say V is equal to U plus AT like that. So V is equal to, what is the initial velocity for bore number 1? It is 0 plus, what is the acceleration? It is 9.81. And what is the time? It is 2 seconds when they met. So the final velocity of bore number 1 will be equal to what? It will be equal to 9.81 multiplied by 2. 19.62 meters per second. For bore number 2, so we're going to say VB2 like this. The velocity of bore number 2 will be equal to, the initial velocity was 50 minus, since we're saying plus 80, here it's going to be minus, since it's going up, 9.81 multiplied by 2 seconds like this. So VB2 will be equal to 50 minus 19.62. So VB2 will be equal to 50, 30.38 meters per second. Okay, so those are the velocities when these bores met. I wanted to say when these two bores met. Now it feels wrong, right? Anyone with a question? Is there anyone with a specific question? Let's look at something else. And this one, I guess it should be the last question. Question 14 is saying, oh, is it 14 or 13? It's 13. Question 13 is saying a projectile is launched at an angle of 30 degrees with an initial velocity v0 is equal to 20 meters per second. What is the maximum height reached by the projectile? And question B, what is the total time of flight? What is the range of the projectile? What is the range of the projectile? So here, it's from the way they've given this question, they haven't mentioned whether the projectile is at a certain height or it's down below altitude for a certain height. No, which means we're going to assume it's on a level ground. So it's starting from a level ground and also falling at the same level. So we'll consider this as a symmetrical diagram. And that means we can use those formulas that we derived that day. Okay, so so we have 30 degrees and 20 meters per second. So if we want to draw our diagram, we'll say starting from that point, going up and falling to that point, then this is the x-plane. So this is 30 degrees, and the initial velocity there is 20 meters per second. So the first question they've asked is, what is the maximum height reached by the projectile? What is the maximum height reached by the projectile? So this height, which is here, h, how are we going to calculate our maximum height? Of course, this is in the y-axis. So which formula can we use here? Hello, so we can use v squared is equal to u squared plus 2as like this. We know to say the final velocity, because it's reaching the top, will be 0. The initial velocity we're supposed to calculate. The acceleration is negative 9.81. So what is the initial velocity? The initial velocity will be the velocity in the y-axis. So it's going to be 20 sine 30 degrees, giving me 10 meters per second. So u squared, or u, will be like that, 10 squared plus 2, negative 9.81. And the distance that we are looking for here, s. Okay, so this will be equal to 100 plus 19.62 s, or plus negative 19.62 s. So 19.62 s will be equal to 100, like that, over 19.62, even here over 19.62. So I'll cancel out this. I'm going to have my displacement in the y, like that, being equal to 100 divided by 19.62. So this is giving me 5.1. It's 5.09. I can just say it's 5.1 meters, like that. Are we together?
Yes.
Okay, question 2 is saying calculate the time of flight. So which equation can we use to calculate the time of flight? If you remember what we discussed that day or last week. It's not a long time ago, right? It's last week. Which equation can we use in order for us to find the maximum height? Okay, so we said for time of flight, this is equal to what? It is equal to, if you want to calculate time from the ground up to the point the stone reaches its maximum height, we said it is equal to u sine theta over g. But then since it's the total time of flight they're talking about here, we're just going to multiply this guy by 2. And the formula thereby changes to 2 multiplied by u sine theta over gravity, like that. So which means this is going to give us 2 multiplied by, what is the initial velocity? The initial velocity is 20 sine 30 over 9.81. Okay, so we're going to have, we found to say 20 sine 30 is 10, which means 2 times 10 is going to give us 20. So 20 over 9.81. This is going to give us how much?
Got a question.
Yes.
The time we did 20 sine 30, it gave us 10. Wasn't that 10 the initial?
Yes, it's the initial velocity in the y-axis.
So like here, we're not using that 10.
No, we are using the formula just says u, not u in the y or in the x. We derived these formulas and it just says u, which means it's velocity in the entire velocity. But since we're multiplying it by sine 30, it can give us that kind of impression to say, oh, it's going to be 10 because we're dealing with time, and time mostly we calculate it using motion in the y-axis. So that's why we're saying sine theta, but these equations are derived. So when you see u in these equations, the derived equations, you shouldn't start overthinking. Just get the same initial velocity they've given you in the question and plug it there. Don't put in the y or in the x.
All right.
Yes, unless you've decided to use motion in the y on your own. If you say, okay, I'll just use those two simple equations whereby you just want to say, maybe you want to say V is equal to U plus AT. You've used that simple equations because you've forgotten the complex equations for projectile motion. You can make sure you resolve the velocities and put them in the y-axis only before you start working with them.
All right.
Okay, so 20 divided by 9.81. So it's giving me 2.04, which means our time is 2.04 seconds. Okay, the last question is saying calculate the horizontal range. So we said range is equal to what? It's either you're going to use that complex formula for range or you use the simplified one. For which the simplified one, we are going to say S is equal to UT plus half AT squared. But since there's no acceleration in the x-axis, it takes out this part of the equation. So we're going to remain with S is equal to UT. But remember, since you've decided to use this simplified formula, what are we going to do? You are supposed to convert your velocity into its x component because the range is only in the x component. So we're going to say S, which is the range, is equal to 20 cos 30. This is velocity multiplied by t, of which the time we've calculated to say it's 2.04 seconds. So displacement is equal to 20 multiplied 20 cos 30 I'm getting 17.32, and this multiplied by 2.04 like this. Therefore our S is equal to 35.3 meters. Any question? Any question? Okay, so when I reach this part, that means for today we are done. It's now 23 hours. At least we've looked at one or two questions under motion. So we've stopped at this question. And at least we've seen how they phrase questions, how they are going to ask you questions. And hence, you should be able to revise even on your own. At least you should be able to answer different kinds of questions. Whatever they throw at you, you should be able to brainstorm and give it a try.